Hello everyone, my name is Amanpreet Singh Chadha and you are watching me on KGS Engineers AJ YouTube channel. In this session, we will be covering some very interesting numericals and conceptual questions related to civil engineering. So join this session and grow as a civil engineer. Good evening. So join this session so that we can start. So as always, we will be solving some very interesting numericals and you will love these numericals. Good afternoon. Good afternoon. Good afternoon. So we solved some very interesting questions in the morning at 11 a.m. and in this session at 4 p.m. we will be solving some more questions. I certainly believe this. If you are regularly joining these sessions will help you in clearing your target exam. You will ace your exam. Good afternoon. Evening starts after 5 p.m. So one more important thing is that we are launching a civil engineering ITI Foundation Batch in Hindi language, and this batch will 100% give you an edge over other students, and I am firmly sure that you will be able to crack the exam you are targeting. This batch has tech as well as non-tech syllabus coverage. And one more thing, the price of this batch is the least you will find on any edtech platform. I can assure you this. Vikal, good afternoon. So, bacho, let's start the session. Let's solve some very interesting numericals. So, the first question says a simply supported beam carrying a UDL of 10 kilonewton per meter over the whole span of 3 meter. What will be the maximum bending moment? So, what will be the maximum bending moment? This is the first question. Date of the launching of the batch is first week of June. We will be launching it on first week of June. Classes will be commenced from mid of June. Good afternoon, good afternoon, good afternoon. So, pyare bachcho, this is a very simple question as far as your standard goes. You people are very intelligent. So, the maximum bending moment will be WL square by 8. W is 10. L is 3, which is 9 by 8. So, 90 by 8. This will be 11.25. Now, if I ask you for the same question, can you tell me what is the value of maximum shear force? For the same data, can you tell me the value of maximum shear force? Good evening. What is the value of maximum shear force? Date of launching of the batch. I give you the exact date now. I say first week. Now I'll give you the date. It is second of June. So on 2nd of June, we will launch our new batch. And this batch will cover tech as well as non-tech, and at a price that you will need to pinch yourself to make sure that you are not dreaming, and with the quality content. Now the maximum shear force for this case will be WL by 2. So W is 10, L is 3 by 2. So this value is 15 kilonewton. What will be the Euler buckling load of a column when it is fixed at one end and the other end is free? This is L square. The main thing is effective length will be one end is fixed, other is free, 2L. So Euler's load will be pi square EI upon 4L square. So these are all L square. L square. Okay, can anyone give me the value of Rankine's constant? Small a. This is equals to sigma c divided by what? Can anyone give me the value of Rankine's constant? This is sigma c divided by what? This question has been asked several times in various competitive exams. Rankine's constant. Sigma c upon pi only, nothing else. So as I can see, very few students know the answer of this question. So let me solve this for you, because this question is an important one and regularly asked in competitive exams. So the Rankine load is 1 upon PC plus 1 upon PE. So Rankine load is PC into PE, PC plus PE. So Rankine load is PCPE upon PC plus PE. Now divide this value by PE. So this is PC upon 1 plus PC upon PE. Now PC is sigma C into A. Crushing load is crushing strength into area. 1 plus sigma C into A. PE is pi square EI upon LE square. So this is sigma C upon A, 1 plus sigma C upon A, pi square E. In place of I am writing down AK square upon LE square. Now this sigma C pi square E, this is Rankine's constant. So Rankine constant is sigma C upon pi square E. हाँ मेरे बच्चे बिल्कुल लाएंगे क्लासेस. इनफैक्ट टेक्निकल सिलेबस सब कॉम्पिटिटिव एग्जाम्स का सेम होता है. तो as far as the civil engineering goes, be it UP exam, be it Rajasthan, be it Madhya Pradesh, be it Karnataka, be it any state exam, the technical syllabus is 90 to 95% same. So this session will help you in any technical exam related to civil engineering. This session at 4 p.m. the only difference is in this session I am speaking in English. One more session I conduct in the morning at 11 a.m. That session is in Hindi. Both these sessions will 100% help you in securing any civil engineering exam. So moving on to the next question, and let's shuffle the questions. Now the depth of flow of water at a certain section of a rectangular channel of 4 meter wide is 0.5. The discharge through the channel is 16 meter cube per second. If a hydraulic jump takes place on the downstream side, find the depth of flow after the jump. So they have asked you about Y2. Very interesting question. The depth of flow is given before the jump. What is the depth of flow after the jump? Very interesting question. If you are able to solve this one, 100% it will help you. सेम बच्चे BTSC लैब असिस्टेंट के लिए भी ये क्लासेस सफिशिएंट है. दिस वन और जो मॉर्निंग होती है 11 AM. Now how to solve this question? You need to build the approach first. What they have asked you? They have asked you Y2. Now you should know that Y2 upon Y1 is 1 by 2 minus 1 plus 1 plus 8 F1 square. Now if you had Froude number before the jump, then this question can be solved. Now Froude number for rectangular channel is V upon under root GY. V is Q upon area is BY under root GY. For F1 this is Y1 and here. So discharge is 16. Width is 4. This is 0.5. G is 9.81 into 0.5. So we can find the value of F1 from here and then can put it here. Y1 is 0.5. We can get the answer. So this is under root 9.81 into 0.5. 16 by 4 by 0.5 pi answer. So the Froude number is 3.612. Now put this value here. So Y2, Y1 is 0.5. So the square of this value multiplied by 8 plus 1 root of this value minus 1 divided by 2 and then multiplied by 0.5. 2.316. Very, very, very interesting question. Definitely deserves a tree. बच्चों कैसा लगा क्वेश्चन? Liked the concept, or I should say loved the concept. A pure conceptual question. The thing you should say, Obito, is the theory of open channel flow is easy. It is among the smallest subjects. If you see the number of chapters, the number of topics in open channel flow, it is among the smallest subject, but it can have the questions as interesting as this one. So it's a very interesting subject. We know this. In case of hydraulic jump, there are only 4 formulas. The entire hydraulic jump concept is based on 4 formulas. One I have written here. Another one is y2 minus y1 whole cube divided by 4 times y1 y2. The other one is y1 y2 into y1 plus y2 equals to 2q square upon gb cube. So the entire topic is based on these formulas. And you must have known also that some of these formulas will be applied. But the thing is to apply them. And now how you become better in solving numericals? It is practice. There is no other way to get better apart from practice. Now let's say someone among you tried to solve this numerical and was unable to do so. So this is not something to be disheartened. So don't think that without giving the practice you would be able to solve the numerical. Think it in a very simple way. You are trying to be a good batsman. Without practicing in the nets, you go straight forward to the match, and now you are thinking that once the bowler will throw the ball at you, and you will just fling your bat and you will be able to cover a six or something. That's not possible. तो तुक्का बोलते हैं, fluke. So in order to solve such numericals, you need to practice first. A rain gauge which is non-automatic type, which is used by Meteorological Department of Government of India. Which one is this? Good evening. Oh, this one is easy. This is Simon's rain gauge. Compute the maximum capillary tension for a tube of 0.007 mm in diameter. Before solving this question, first we'll solve this one. This one is extremely easy. Porosity is 30%. What is void ratio? N upon 1 minus N. 0.3 by 0.7. 3 by 7. 0.428. देखो बच्चों, once you see the question, the calculations should immediately start in your brain. You need to increase your brain activity. The moment you see a question, you should become your calculation should become like a supercomputer. The sum of suction head and delivery head is known as what? The sum of suction head and delivery head is known as what? This is known as static head. Now, a few days back, I give you a code in order to understand a certain equation. My question to you is, in Reynolds equation, which force you ignore? In Reynolds equation, which force you ignore? Let's see how many of you remember this. Good. And we have made a code for this as well, RCB. So in case of Reynolds, we ignore, भूल जाते हैं हम, which force? Compressible force. So you ignore compressible force. So if you will make the codes, it will definitely help you. Just one last thing. In case of Navier-Stokes, for Navier-Stokes equation, which force we ignore? Very good. For Navier-Stokes, we ignore turbulent. A curve or contour connecting all points below the ground surface of equal vertical pressure. Very easy question. A curve or contour connecting all points below the ground surface of equal vertical pressure. This is isobar. In fact, isobars are known as stress contour. Isobars are also known as stress contours. A 25 centimeter diameter pipe carries the oil of a specific gravity this at a velocity this. At another section, the diameter is this. What is the velocity? This is clearly the case of continuity equation. So velocity is 3. Pi by 4 is cancelled out. 25 into 25 divided by 20 into 20. Now this is the velocity. 5 by 4, 5 by 4. So 5, 5, 25, 75 by 60. So 64 is 4 times. The option. Extremely easy question. Which type of acceleration is this one? Which type of acceleration I have shown in the block? This is convective acceleration. My question to you is, when this value is 0, for which case convective acceleration is 0? For which case convective acceleration is 0? Which type of flow? Very good. For uniform flow. A soil has a bulk density this, water content this. What is the dry density? Extremely easy question. So gamma T upon 1 plus W is gamma D. These type of questions, they are frequently asked in competitive exams. So this is 20 kilonewton per meter. Extremely easy. Work out the theoretical maximum dry density for a soil sample having a specific gravity this, optimum moisture content this. So bachcho, they have asked you the theoretical maximum dry density. Means they have asked you ZAVD. This is G gamma W upon 1 plus WG. Because in case of ZAVD, the degree of saturation is 100%. So G is 2.7, gamma W is 1 because all the data is in gram per centimeter cube. Water content is 0.19. G is 2.7. .7845. Option C. A real fluid in which the shear stress is directly proportional to the rate of shear strain. Now, I believe we have done so many questions. We have learned the concept of Newton's law of viscosity so much extensively that this type of question should be counted as a very simple question for you. This is Newtonian fluid. Few days back, I asked you the examples of Newtonian fluid. Can you just name me two examples of Newtonian fluids? Just two examples of Newtonian fluids. Yes, this is water and alcohol. So thixotropic, rheopectic. I hope you know everything about time dependent, time independent. The allowable maximum settlement for commercial building is what? Now this is a entirely code based question. If you have read the code, you will be able to answer this one easily. The allowable maximum settlement for commercial building is what? As they have not asked that which type of soil it is, so we will be going that it might be a case of differential settlement. We'll go with 25 mm. The question should have been framed a bit more clearly, but with the given options, we'll go with option D. Determine the value of critical hydraulic gradient for a loose deposit of sand having a void ratio this and specific gravity this. So this is G minus 1 upon 1 plus E, D option. Now a very interesting question. Let's see how many of you are able to solve this one. So we have a stream tube. And at the beginning of the stream tube, the velocity is 2.5 meter per second. And at the end is 3.5 meter per second. So in the beginning of the stream tube, the velocity is 2.5 meter per second, and at the end of stream tube, this is 3.5 meter per second. The length of the stream tube is 20 centimeter. Find out the convective acceleration at the midpoint of the stream tube. The question is in a stream tube. This question is very interesting. It has been asked in JEE, AE, ESE exams. So in the beginning of the stream tube, the velocity is 2.5 meter per second. At the end, it is 3.5 meter per second. The length of the stream tube is 20 centimeter. What is the convective acceleration at the midpoint? Now, if you are able to solve this question, I am assuring you that you will be able to clear any competitive exam related to civil engineering. Because this question will only be solved by those students who really have put the effort. Those who have just crammed Ratna, those who have just crammed throughout various notes, they won't be able to solve this one. First of all, mere bache, convective acceleration, the unit should not be meter per second. Now, what is convective acceleration? This is V, del V by del X. Now, del V is change in velocity. Change in velocity is 3.5 minus 2.5. Del X is length. What is the length? 0.2 meter multiplied by velocity. Velocity where? At the midpoint. Because you need to find out the convective acceleration at the midpoint. Now, what is the velocity at midpoint? Take the average. Take the average of what? 2.5 and 3.5. So, 2.5 plus 3.5, 6 divided by 2. So, this should be 3. So this should be 3 into 1 divided by 0.2. 15 meter per second square. But you got the value correct, Obito. So very good. Good evening. So though you got the SI unit wrong, but you got the concept correct. So I will give you marks. And I can assure you this, that if you continue on this path, you will have the job, you will have the career you want. So moving on to the next question. But water is flowing through a pipe of diameter this with velocity this. Find the Reynolds number if the kinematic viscosity of water is this. So we know that there's a simple expression. Reynolds number is rho Vd by mu. Means Vd by eta. So what is the velocity? Velocity is 3, diameter is 0.2 and this is 0.01. So 3 to 6. Answer is option C. Hydraulic jump occurs when a supercritical stream meets a subcritical stream, when a supercritical stream meets a critical stream. So among the simplest questions in the entire of the civil engineering, student who is putting even half of the effort still would be able to answer this question. So a hydraulic jump occurs when a supercritical stream meets a subcritical stream. So statement first is true, second is false. Answer is option A. One more question is that hydraulic jump occurs when a steep slope meets a mild slope. A pitot static tube is used to measure the velocity of water in a pipe. The stagnation pressure head is this, static pressure head is this. Calculate the velocity of flow. Assuming the coefficient of velocity is 0.98. भैया मैं चेक कर लूँ which question. अच्छा मैंने उल्टा लिख दिया ये, sorry. Statement 1. Now here the velocity will be CV under root 2GH. This value is 0.98. G is 9.81. Net head is 1. So 4.34 meter per second. Just tell me dP upon rho plus G dz plus V del V is equals to 0. Which equation is this? Which equation is this? Very good. This is the Euler's equation. Very good. Now, in order to get Bernoulli equation, if I want to get Bernoulli's equation from Euler's equation, what I need to do? Very good. So if I integrate the Euler's equation, I get Bernoulli's equation. One more question. Which forces do we consider in Euler's equation? Which forces do we consider in Euler's equation? We consider gravity force and pressure force. Negative skin friction on a pile under vertical compressive loads. Almost the same question was also covered in the morning session. No, not viscous bache. It is gravity and pressure. So if you know the diagrammatic representation of negative skin friction, then you can easily solve this question. So this is the load. Actually, the skin friction acts in the direction opposite to the load, but in case of negative skin friction acts in the direction of the loading. So it acts downwards and reduce the load carrying capacity of the pile. Have I written the correct expression for negative skin friction in cohesive soils? Is this the value of negative skin friction in cohesive soils? बच्चे न्यू फाउंडेशन बैच लॉन्च हो रहा है 2 जून को. बच्चों, please keep this in your mind that the expression of negative skin friction is also asked in competitive exams. Let's represent it as Q dash. Very good. Almost everyone. Price will be the least among all the edtech platforms. This I can assure. The actual price we will reveal on the day of the launching of the batch. So, pyare bachcho, what is the expression for QF? It is FSAS. Now, Fs is alpha Cu. Surface area of the pile is parameter into length. Just remember it by this way, that in case of negative skin friction, we put this alpha as 1. So this is the correct expression. CUPL. Cu is undrained cohesive strength, P is parameter, and L is embedded length. So the actual load carrying capacity, this QF, this Q dash F is this value. So the load carrying capacity of the pile reduces. The dimension quantity for angular velocity is what? Extremely easy. What is the dimension of angular velocity? Now, you have answered the question extremely well. My question is, in case of forced vortex flow, what is the relation between velocity and radius. So what is the value of n? Is it 1? Is it 2? Is it -1 means inversely proportional, or is it -2? In case of forced, please make sure you are hearing me correctly. Forced vortex flow, not free. In case of forced vortex flow, what is the relation between velocity and radius? Good. In case of forced, velocity is directly proportional to the radius, whereas in case of free vortex flow, velocity is inversely proportional to radius. Mode of failure in a very deep footing in dense sand is which one? Mode of failure in a very deep footing in dense sand is which one? Punching shear failure. Very good. Bacho, can you tell me which type of shallow foundation is this? Which type of shallow foundation are you seeing on the screen? Extremely easy. This is strap footing. But the main question is, when do we use strap footing? When do we use strap footing? In which case do we use strap footing? This is my question is. क्या बात है भाई, बहुत बढ़िया, very good. Strap footing is used in case of unequal, means in case of differential settlement. Very good. The coefficient of permeability of silt is what? The coefficient of permeability of silt. Yes, uneven settlement is known as differential settlement. This is option A. So make sure you are well aware with the table of permeability for various soils. Just a simple question. Can you give me an example of a very famous structure which has undergone differential settlement? Can you name a very famous structure which has undergone differential settlement, means unequal settlement? Giza pyramid. Giza pyramid has undergone. It is not Giza. It sounds like Giza, but it is Leaning Tower of Pisa. It is the Leaning Tower of Pisa. Pisa is a city in Italy. So you must be, you have seen, I am sure you must have seen that image where the building is like this. It has shown differential settlement, unequal settlement, and due to this unequal settlement, the building has tilted. And in fact, when the building was in the middle of its construction, already it was showing differential settlement. when this building was being constructed, it was already showing the signs of differential settlement. But the engineers at that time, this building is extremely old. It's hundreds of centuries old. So hundreds of years old. So though they were able to find out that this building has already undergoing the differential settlement, but they kept constructing it. So in a way, this is a very infamous example of engineering. Something like this should not happen. But as it has become a unique example, it has become infamous. The word is not famous. Famous is आप अच्छाई के लिए फेमस हो गए, आप अच्छे काम के लिए फेमस हो. It's like the opposite of famous, infamous. A three-hinged arch of span L, central rise H is subjected to a UDL. What is the bending moment at L by 4? What is the bending moment at L by 4? So, बच्चे, in case of a three-hinged arch subjected to a UDL, the bending moment is not induced. The ordinate of influence line diagram for a bending moment always will be what? Interesting question. The ILD, if you make the ILD for the bending moment diagram, for the bending moment, what will be the unit at the y-axis? Is it force, force upon length, force into length, or length? It is length. Interesting question. The final deflection due to all loads, including the effect of temperature, creep and shrinkage, should not normally exceed what? It should be span by 250. प्यारे मेरे बच्चों, are you sharing this session with your friends who are more comfortable in English? या मजा ही लाई जाने हो सवेरे हिंदी च ते शामी अंग्रेजी च पढ़ लांगे. So I hope this session is also reaching those students who are more comfortable in English. So I want this session to reach every student, be the person speaks in Hindi or in English, but the session I want that it also should reach the targeted audience as well, the English speaking audience. The stress in a steel bar is this, length of the bar is this, what is the shortening? So this is the formula based question. Sigma L upon E. 2, 5, 1, 2, 3, 4, length is 42.14. The reason I am writing it down in such an arbitrary form is because all the numbers are different. So we can get a clear value. 100 divided by 2, 50. Answer should be less than 50. D option. Chalo, let's solve one more question and the rest of the questions we will be solving tomorrow. Resilience is known as what? Very easy. So resilience is known as what? Strain energy not at elastic limit, not at elastic limit, within elastic limit. Strain energy up to fracture point, this is toughness. So प्यारे मेरे बच्चों, we are done for today. And the interesting thing is that we are launching the JEE Foundation Batch on 2nd of June. Classes will be commencing from mid of June. So if you really want to give your preparation an edge over all the other students, if you want to get the concepts feed into your brain and you want to see the PPTs where AI is integrated, so you must join this batch. I assure you this batch will give you wings and this will give you the edge you need. This will give you the career you carve. देख रहा हूं अंग्रेजी. To be or not to. Yes. So but you know, I'll see you 11 a.m. in the morning tomorrow. Till then, do take care. God bless you. Thank you.